Hi everyone. Today I'm going to be discussing probability with you. What I'm going to be working through is just the basics of probability. We're going to be talking about the probability scale as well as the correct notation for probability. So if we start with the probability scale, we know that probability is measured between 0 and 1. Now, when we write probability, we can write probability as a whole number, as a fraction, as a decimal, or as a percentage. So if we were looking at the value of 0 and I wanted to write it as a percentage, I would write it as 0% and 1 being 100%. Now, as you can imagine, in between 0 and 1, directly in the middle, we have our 50% mark. Okay, so our 50% mark would be represented as either 0.5 or as 1 over 2 or as 50%. So that is directly in the middle. Now, if we're looking at our probability scale, 0 or 0% would be an impossible outcome, or it wouldn't happen. Whereas if I look at our 1 or our 100%, that will be a certain outcome. So it's definitely going to happen. When we talk about our 50%, right in the middle, that's a 50-50 chance, right? So that would be an equally likely outcome. Now, probability is an experiment. So probability is the outcome, the favorable outcomes over the possible outcomes, and we would represent it possibly on a probability scale. Now, in the probability scale between 0 and 1, we also have our other values. For example, we have our 25 or our 75%. So we have our 25% or we have our 75%. We could also have 60%, we could have 65%, we could have 33%. Everything between 0 and 1. So that's our probability. So like I said, probability is measured between 0 and 1, and it's the favorable outcomes. Probability is represented as the favorable outcomes over the possible outcomes. So if, for example, I were looking at a dice, okay, so let's say, for example, the experiment with the dice would be rolling the dice. And when I write out my probability, I'm going to write it with a capital P. And then in brackets, I'm going to say what I want the event to be. So, for example, if I were to say, what is the probability of rolling an even number? So, probability of an even number. So what I would do is I would look at my dice and I'd say, all right, how many outcomes do I have? 1, 2, 3, 4, 5, 6. If I throw my dice, it's going to land on one of 6 options. So when I'm writing out the probability, it's the favorable outcomes over the possible outcomes. So if I were to look at the possible outcomes, I know that my possible outcomes is 6. So my fraction is going to be out of 6. But my event that I'm looking at here is throwing an even number. So if I were to throw an even number, it would have to land on number 1, 2, 4, or 6. So that gives me 3 favorable outcomes. So 3 even numbers out of 6 in total. We're going to write it as a non-simplified fraction and then as a simplified fraction. So 3 goes into 3 once, 3 goes into 6 twice. So I have the probability of throwing an even number being 3 out of 6 or 1 out of 2. If I were to say to you, what is the probability of throwing a 4? Okay, so that will be favorable outcomes over possible outcomes. So if I want to know what is the probability of throwing a 4, I need to decide how many 4s I have in total on my dice. So I only have 1 4 on my dice. So that means that there's a 1 chance, there's only 1 4, out of the total number of chances that I have, or total number of outcomes that I have, which is 6. So the probability of it landing on a 4 would be 1 out of 6. Now this brings me to the probability of something happening or the probability of something not happening. For example, if I were to say to you, the probability of it landing on a 4 is 1 out of 6. So I said to you, what is the probability of the dice landing on a 3? Then if we were to say, what's the probability of it landing on a 3? We'd say, how many 3s do we have? Well, we have 1 3. Out of how many outcomes are there in total? There are 6 outcomes. So that's the probability that this dice would land on a 3. So I would be able to say to you, what is the probability of it not landing on a 3? Okay, so now I'm changing it up just a little bit and I'm saying, what is the probability of it not landing on a 3? So if the probability of it landing on a 3 is 1 out of 6, then the probability of it not landing on a 3 would be it landing on 1, a 2, a 4, a 5, or a 6. So that means that there are 5 possible outcomes that aren't 3 out of the 6 outcomes in total. Alright, so I have a 1 out of 6 chance of it landing on a 3, and I have a 5 out of 6 chance of it not landing on a 3. So if I were to look at that, there could be another way that I could write this. Alright, so this is bringing us to the notation. So the probability of the dice landing on a 3 versus the probability of it not landing on a 3. Now I don't want to have to write out not landing on a 3. So I'll say the probability of it not landing on a 3. And that prime, tells me that I'm working with not a 3. Okay, so if I'm talking about the probability of it landing on a 3, I'd say the probability of it landing on a 3, well, there's 1 3 out of 6 possibilities. Versus the probability of it not landing on a 3. So we counted the possible outcomes, but there needs to be another way that we can do it. So probability, the total of probability is out of 1. So the probability of it not landing on a 3 would be the full probability of this event occurring. So the full probability, which is 1, minus the probability of it landing on a 3, because that's the only outcome that won't satisfy not a 3. So that means that we could write it as 1 minus the probability of it landing on a 3, which is 1 out of 6, and 1 minus 1 out of 6 gives me my 5 out of 6. So the probability of it landing on a 3 is 1 out of 6. And then we have the probability of it not landing on a 3. And that's my probability, which is 1 minus the probability of it landing on a 3. 1 minus 1 out of 6, which gives me my 5 out of 6. Alright, if I look at another example, and I'm going to look at an example of a deck of cards. So if I look at this deck of cards over here, there are multiple different ways that this question could be asked. So the first thing that we need to know when working with a deck of cards is that we have 4 suits. So the events that could be occurring are different types of events. So we could maybe have an event of drawing a black card. We could have an event of drawing a red card. We could have an event of drawing just a club. We could have an event of drawing just a heart. So depending on the event will determine what my probability looks like. But a deck of cards has 52 cards in total. So if I said to you, what is the probability of drawing a king? Okay, so now we're talking about a king. So K, I'm just writing a K to just shorthand it. So this we're talking about a king. So what is the probability of drawing a king out of this deck of cards? So the first thing that I'm going to do is I'm going to identify how many cards I have in total. So I have 52 cards in total, but I want to know what the probability of drawing a king would be. So how many kings do I have? I have 1, 2, 3, 4 kings out of the 52 cards in total. So the probability of drawing a king would be 4 out of 52, but that can be simplified. 4 goes into 4 once, and 4 goes into 52 13 times. So I actually have a 1 out of 13 probability of drawing a king. If I said, what is the probability of drawing an ace? So now, the probability of drawing an ace, I'm not specifying which ace I want to draw. I'm just saying I want to draw an ace. So I'm going to count how many aces do I have in this deck of cards. I have 4 aces because the ace wasn't specified out of 52 cards in total, and 4 out of 52 simplifies down as to 1 over 13. Alright, then I can make it more specific and I can say, what is the probability of drawing the ace of hearts? So now I'm specifically talking about a specific ace, and I want the ace of hearts. So if I look at the ace of hearts, you can see over here, there's only 1 ace of hearts. So now I have 1 out of 52. So I have a 1 out of 52 chance of drawing the ace of hearts specifically. Alright, so now if I were to work with it, the probability of drawing something versus the probability of not drawing it, if I said to you, what is the probability of drawing a 7, we would say, okay, how many 7s do you have in a deck of cards? We have 4 7s in a deck of cards out of the 52 cards in total. So that means that we have a 1 out of 13 chance of drawing a 7. So what is the probability of not drawing a 7? So that would be 1 minus the probability of drawing a 7. So that gives me 1 minus the 1 out of 13, which gives me a 12 out of 13 chance of not drawing a 7. And we could do that throughout. So I'll just do one more example with you regarding the card. So what is the probability of drawing a red 5? Okay, so if I were to draw a red 5, how many 5s do I have in the deck of cards? I have 4 5s in total, but 2 of them are red and 2 of them are black. So to draw a red 5 would mean that I need to either draw the the 5 of hearts or the 5 of diamonds. So that means that I have 2 options now out of still the 52 cards, which simplifies down as 1 over 26. Alright, so I could then say, what is the probability of not drawing a red 5? Alright, so that would be not drawing the red 5. So the total probability is 1 minus the probability of drawing a red 5, which is 1 out of 26, which means that the probability of not drawing a red 5 would be 25 out of 26. That would be the probability of not drawing a red 5. Alright, if we look at these 3 quick examples, it says Leah has 12 cards, each with a shape on it. She takes a card at random. What is the probability that Leah takes a card with a star on it? So if we look at question A, we want the probability of the card having a star on it. Alright, so we have 12 cards in total. How many have stars on them? Well, if we look, we only have 1 card with a star. So the probability of a star is equal to, how many stars do we have? We have 1 star out of, how many cards do we have in total? 12. So the 1 out of 12 chance of it being a star. What is the probability of it being a triangle? Now, if we look at the triangles, now we want it to have a triangle on it, and we have 1, 2, 3, 4, 5 triangles. So the probability of it having a triangle is 5 out of the total number of probabilities or outcomes, which is 12. 5 out of 12 chance of it having a triangle on it. And what is the probability of it having a circle on it? So now if we're looking for the circles, we have 1, 2, 3, 4, 5. 6 of these cards have circles on them. Out of, how many cards are there in total? 12. And 6 goes into 6 once, 6 goes into 12 2 times. So there's a 1 out of 2 chance of drawing a circle. Alright, if we look at this next one, now we're working with decimals. The Wanderers play a match of football. The probability that they win the match is 0.28. So winning is 0.28. The probability that they draw is 0.55. And now it's asking us to work out the probability that they lose the match. So we have the probability of them winning being 0.28. We have the probability of them drawing the game as 0.55. So we want to know what is the probability that they lose the match. Alright, so we know that the total probability is out of 1. Okay, so therefore that means that the probability of them winning, along with the probability of them drawing the game, along with the probability of them losing the game, needs to equal 1. So the probability that they win is 0.28 plus the probability that they draw, which is 0.55, plus the probability that they lose the game, and them losing the game is what we're trying to calculate, and it's just a simple equation, is going to total 1. So that means that the probability of them losing will equal 1 minus the 0.28 minus the 0.55, which gives us a probability of them losing being 0.17. Alright, last example. The table shows the shoe sizes of 23 students. So now we have shoe size 5, 6, 7, 8, and 9, and the frequency being 2, 11, 5, 4, and 1. A student is picked at random. Question A says, work out the probability that the student has a school size of 8. Alright, so we're looking for the size 8. So how many have the size 8? So we have 4. But the first thing that we need to know is we need to know how many students we're working with, and we're working with 23 students. So what is the probability of the student wearing a size 8? Well, how many people wear size 8? That's 4. Out of how many students are there in total? 23, and that's fully simplified. Question B says, work out the probability that the student has school size of 7 or smaller. So now we're looking for 7 or smaller. So what does that mean? It needs to be size 7, but then all the sizes that are smaller than size 7, which is size 6 and size 5 as well. So the probability of being 7 or smaller, well, the total number of students is 23. The probability of them wearing a size 7 is 5. Plus the probability of them wearing the size 6, which is 11, plus the probability of them wearing size 5, which is 2. So the probability of them wearing a 7 or smaller will be 18 out of 23. I hope that this has helped.